that video was really cool, huh?
Yeah.
Yeah, so what you saw there was they took all of the air out of the tube, and the penny and the feather, they fell at the same time.
Yep.
Okay, at negative 9.8 meters per second squared. Okay, what do we have here? Palm trees.
In a wind. The wind be blowing.
The faster the wind blows, the greater the force it exerts.
Yep.
When we first moved here from, we lived on the East Coast. My little sister Delia, who Mr. Boykin knows, we were like 6 when she first moved here, and she was 4, and she was like, "Oh my gosh, we're in California Palm Tree World!" And she just said that over and over again. So that's what these remind me of. Okay, so a skydiver steps out of a balloon. As she falls, what happens to the velocity, the weight, air resistance, net force, and acceleration?
This sounds familiar to me. They should have this.
You should. We took notes on this in our last video, I think it was.
Can you answer these questions right now at the top of your head?
Can you do it?
Let's do that thing that allows us to answer it. What was that thing?
Okay. Oh, let me go back. Sorry. I thought it was on our next one here. So let's go ahead and
No.
create
Let's just do the reading.
Oh, the reading.
Because see, we're going to have this again later.
Oh, that's right. That's what I thought. Okay. Okay. So you should have answered those questions. Now I want you to pause the video and you're going to go to the book. You're going to go to the e-text. We are in chapter 6. I want you to go to page 134 and read the first 3 paragraphs. Right here, starting with air drag and terminal velocity. And I want you to read with a purpose. Your purpose is, well, when you're done reading, the expectation is that you can... That's good. That's okay. The expectation is that you could explain this to someone else.
All right. Go ahead, pause the video, read, and then come back to us.
We ready?
We're ready.
Okay, so now going back to our question about what is happening to the velocity, the weight, and air resistance, net force, and acceleration as the skydiver steps out of the plane. In order to answer that question, let's go ahead and do these free body diagrams again.
You do them again. We're not going to do them again. We're going to make the
yeah.
dots and whatnot. Make the dots and whatnot.
So the first step is going to be right here. And then what was it, after 2 seconds and 10 seconds?
Yep.
And then the terminal velocity?
Yep.
I'm going to go VT for terminal velocity.
Sure.
Kinda
Don't forget the dot.
Getting lazy. Oh, dot. We need the dot to start.
So in your notes, do this.
And if you're stuck, find where we did this in the last episode, lesson, whatever you want to call it.
That's right.
Okay? So, don't forget, terminal velocity occurs when the air resistance on a falling body equals the weight. So when the air resistance up equals the weight of the person being pulled down, and our net force will be equal to 0 during this time, and our acceleration will be equal to 0 during this time.
Yep.
Okay, so what happens to the velocity? Well, in the very beginning, we should walk through with it.
Yeah,
right?
yeah.
In the very beginning, it'll be 0, right? We haven't fallen yet, or we're just like holding our breath before we go. And then the more and more we fall, the more and more our velocity increases.
Yep.
Now, our weight is going to stay the same.
Yep.
Now, remember, our weight is the force of gravity, and it's dependent upon our mass and negative 9.8.
Yep.
Okay, so it's not going to change. The air resistance.
Well, as you're going faster, what happens to the air resistance?
You're going to have more and more air resistance
It'll
the more and more
increase.
you fall down. So the air resistance is increasing, and then once at the net force.
What happens to the net force? The
well-
weight stays the same, the air resistance increases, so
the net force is going to decrease. It's going to get smaller and smaller and smaller. And then
What's the net
ultimately,
force at terminal velocity?
at terminal velocity, our net force is 0.
That's right.
Which means that our acceleration is also...
So what's going to happen to the acceleration? We end up at 0. We start off at 9.8.
Well, it's decreasing.
Negative, it decreases.
Right? We have a lot of acceleration. We have, well, not here.
Yeah.
Right? Here we have a lot of acceleration. It's going to become less and less and less and less, and ultimately here it becomes 0. Okay.
Okay.
we're still moving really fast, but we're not getting any faster.
Yep.
Oh, there's another movie.
No, that's
Good.
that one that we saw out of the people, the skydiver thing yesterday.
The eye fly.
The hint.
Yes. Oh,
No, the hint.
Oh, okay, yeah, gotcha.
I think that's the hint, yeah.
Hope it's the hint. Okay. What is your mass in kilograms? What is your weight in newtons?
It says lie.
What does that mean? That means if you don't want to use your real weight for whatever reason that is, you're in charge of what you want to use. Make it up.
That's right. Let's say you wanted some more meat on your bone. Add some pounds. Who cares?
Yeah.
If you would like to have less, ain't nobody's business but your own. Just write down a number that you like.
So I stepped on the scale this morning and I'm 155 pounds. Now, in order to go to kilograms, what is your mass? What did we say? We said 2.2. We need a conversion factor. Oh, conversion factor sounds scary. Anyone who lifts weights is familiar with this conversion factor.
Yeah.
For every 1 kilogram, there's 2.2 pounds.
So you can make that equation into a fraction, can't you?
Yeah, we could. We could say this could look two ways. This could look like this, 2.2 pounds, and this equal sign is really just a division bar right here, is 1 kilogram, or it can look like this.
Because you have the same thing on the top of the fraction as on the bottom of the fraction. That's the same as 1. If you got the same thing on the top and the bottom.
So let's go ahead. I like to do my little, set it up like this.
I like
Okay.
that. I like that.
And if I have pounds here, I also need to have pounds here. So which one down here is pounds at the bottom?
That one.
Right there at the bottom. I'm just going to go ahead and copy it in. My pounds right there. And next to pounds is 2.2. And then on top is just 1 kilogram. I'm just going to copy it in there. Okay? Why do I choose this in the bottom?
So you can cancel.
So I can cancel out my units. I'm left with the units of kilograms, which is exactly what we asked for. Now 5.5 divided by, 1.5,
155 times 1 divided by 2.2.
2.2, and I'm going to call it 70.
70 kilograms.
Okay, so what is my mass? For me, it's 70 kilograms. You choose your own mass, whatever that is, and you're going to do the exact same thing, and you're going to get your answer right here.
And write that down in your notes where you can find it. You're going to need that later.
What is your weight in newtons? Okay, well, I know that my weight is the same thing as the force of gravity, which is just mass times gravity, right?
Yep.
So my mass, we just got up here, 70 kilograms, times, what was that number?
9.8.
Always. Okay, so 70 times negative 9.8. And I get negative 686.
So you weigh 686 newtons.
Yeah, and that negative just means that the force of gravity is pulling you down.
So if somebody asks you how much you weigh, give it to them in newtons. It won't make any sense to them. It'll expose their ignorance, which you don't have, right? You know what's going on.
You know
here.
what's going on.
That's
Okay.
right.
All right, and one more question. In a race, you go from rest to 10 meters per second. Wow, that is.
That's fast.
I wonder if you're running, driving. You gotta be driving. In 1.25 seconds, draw a free body diagram of this with the force net included and the acceleration included, just like with our when we were falling, when that skydiver lady was falling, right? Okay. So let me just go ahead and write down the information here. So we have, in a race, we go from rest, initial velocity being 0 meters per second. So we start here, and over a certain amount of time, we end with, what was it?
10 meters per second.
10 meters per second. Okay, so initially, we're going 0 meters per second and running. And how much time did it take us?
1.25 seconds.
Okay, so, and then what are we trying to find here?
Well, they want to draw a free body diagram.
Okay, let's start with that then. Okay, free body diagram. Okay, in a race, so I know what my mass was. What did we just calculate? That was 686 newtons.
Your mass Yeah, that's your weight. Yeah, 680. Sorry.
The force of gravity, I said I'm what, 70 newtons?
70 kilograms.
70 kilograms times, we just did this right here, right?
Yeah. So when you do this, boys and girls, at home or wherever you are right now, use your mass and your weight
So
for
you're gonna
this information.
You'll put your mass right here, which you need to get by dividing your number by
Just like we did a minute ago.
2.2, yeah.
What next?
Okay,
What
so
else we got?
I'm not flying up, right?
Nope.
So that means that these two things are gonna be the same. Force up equals
Whoop.
686 newtons.
All right.
Okay, so this is what I know so far. Draw a free body diagram.
It says the net force in these. How can you find the acceleration?
Okay, so what is this acceleration going to be? Well, okay, hold on. I could say that I'm trying to find acceleration here, right?
Yeah.
And I have no V final, right?
Yeah, you do.
Oh, sorry, I have no, the distance, no
There's
distance,
no
right?
distance, yeah.
So that is going to be, I have the equation, but let's just double check. Oh, no, I don't have my thing
That's the
anymore.
definition of acceleration. That's
Yeah.
V final minus V original over time.
I was going to try and show you guys on my little thing, but you guys know what to do, right?
Yeah.
Okay, so from here, V final is 10 meters per second minus, 0, that makes it easy, divided by my time, which is 1.25 seconds. This just goes away. My acceleration is going to be 10 divided by 1.25, 10, 1.25, and I get 8.
8 meters per second squared.
Now this is a positive 8, which means it's going in the positive direction, right?
Yeah.
So my acceleration is going to be 8 meters per second squared, but most importantly, it's going this way, right?
Yep.
Okay.
Okay, now what's the net force?
Well, we know that the net force is going to be the same direction as the acceleration, right?
How can we find the net force?
How can we find it? Okay, well, let's go ahead and think about, go ahead and write this out. So force net equals mass times acceleration, right?
Yep.
So in order to find this, we need our mass.
Use
We
your
have
mass,
that.
boys and girls.
And we have the acceleration, right?
Yep.
Our mass was 70 kilograms. Well, my mass. And our acceleration we just calculated was 8 meters per second squared. How come we're not using negative 9.8?
Because it's not down. It's not the weight. It's the acceleration that's because you was a runner here.
Nothing's falling here. We're running, okay? So I've got 70 times 8. That's going to be 560 newtons. Okay.
560 newtons. I
So
think
we know our net force is going to be 560 newtons this way.
Yep.
Now we can't actually know, we know that there is some, the force of you propelling yourself forward, right?
Yep.
The force of you. And then we know that we have a force of friction, the force of air resistance kind of
Because you're
pulling
running
back.
through the wind, right?
Yeah, but we can't really calculate those. But
Without more information.
yeah, this answer is a result of these two,
Yep.
right? Oh, the resultant. Oh, okay, these cancel out, so boom, gone.
All right.
Okay, so homework. Page 145, number 5, and page 136, number 4.
So 136, that's right under your,
Oh, over here?
nope, right here. The skydiver.
Oh, right here. Goodness.
I had
Good thing I
had the
checked.
camera in the way, sorry.
I was like, okay, so this one right here, and then 145. Number
Okay.
5 is gonna be that one right there.
Yeah,
and
in the
B.
chapter 6 review.
Ooh, exciting stuff. Okay,
Sweet.
guys, go fight one.